Hi, Nick Collier here, and this is my shop. Come join me. We'll have some fun.
So we're going to come in and heat treat this cutter. But before we do that, I want to do a test run just to make sure that it's doing what I want it to do. So we're going to do it on aluminum. It's not going to harm the cutter one bit. And we'll just go around 16 times every 22.5 degrees. Okay, so let's do that. I guess I better spin it the right way, huh? There we go. Okay, there it's touching. Now what we did is we got the outside diameter and the inside diameter, or I mean, you know, of the teeth themselves, or of the spline itself. And we came up with, and it's now erased. So the outside diameter is 888 thousandths. The inside diameter is 735 thousandths equals 153 thousandths. So divide that by 2 because we've got a gear or a tooth on each side. And we have 76.5 thousandths per side. Now we just touched that, so we know we're at 0. So we're going to do 76.5 thousandths. And I think what I want to do is back it up a bit. Okay, we got the spline done. Now we have to do is deburr it a little bit and cross our fingers and test it out. So let's give it a test run here. we got the phone ringing. Be back. Okay, well, we got close, but no cigar. I mean, it almost fits. You can see it's just about there. But, and it looks like we're just not quite deep enough. So, and you can see I kind of tapped it in with a hammer just a little ways. And lucky it's aluminum and that is steel, so no problem. So we're going to cut it again. This time we're not going to cut the whole distance. We're just going to cut till the center is right about there. Okay, well, I'm still in learning mode with this whole process, and one thing I've learned is to make the shaft oversized, at least in aluminum. Now, I don't know how it's going to go in 4140, but make the shaft oversized and then cut it back, and you'll see why. Because it looks like crap right now, right? But we're going to cut this back. 888, and right now we're sitting at 990, so we got a ways to go. So we'll take 20 at a time. 86. I think we're good with that. Let's go over and see if this is gonna fit. Oh wait, we gotta take a little chamfer off of the top here. And then I'm gonna go the other way and knock off the burrs. We also want to deburr. I don't know, it's looking pretty good. I think we'll just leave it. Alright, well, it still doesn't fit, but it's closer than it's ever been. So we're going to just tap it in a little bit and see where we're at. Okay, can you see? It looks like we're hitting the bottom. Let me get a pointer. There we go. I'm seeing it hitting right at the bottom of that V, and almost nowhere else, just a little bit right here, but the bottom of the V for sure. So that tells me that we need to go deeper. So we're going to go back and do it again. Okay, let's give it a try here. And of course, I've already tried it and I know it works. So I'm pretty excited though. So this really only goes in that far, because I was like, why cut it all the way back? So we just got beyond center, and there it goes. It drops right in, just like it's supposed to. And hardly any movement, just enough for some grease, and I think we're set. Okay, so now that we got, oh, by the way, just so you don't think I'm some kind of god because I figured this thing out right off the bat, that didn't happen, because we're going to spin you around here. You can see how many tries I did in order to make this thing happen. And most of the tries were working my way down to the right diameter, but there was also some other things I had to work out. The bit itself, or I mean the cutter itself, there wasn't enough rake on it, and you know, a couple other things. So now we're going to take the cutter and we're going to heat treat it, because, you know, we're cutting aluminum. So so we're going to heat treat it and then put it back in and cut some 4140, which is this material here, and that'll be good. Okay, the cutter's in the kiln. I've already tested it, make sure I can get my pliers in there and grab it. I got the oil down below here, so we're just going to close this baby up, take her up to 1650 degrees or so, and we're sitting probably at about 250 right now, and this thing goes to 2000, so 1000 to 15, so it's 1650. Yeah, we've got an indicator for 1650. So basically what we'll do is take it up to 1650 and let it sit there for a half an hour. Okay. Then we'll be back. Oh, you didn't see the little indicator right there. All right, so let's pull out our piece. We are at 1600 for the last half hour. We're going to first turn our temp down a bit. And let's get another glove on. Then we're just going to reach in and grab that sucker and get out of there. Woo, it's hot. Drop it in the oil and just slosh it around till it cools off. Not too bad. Still kind of hot. And we want to bring the temp of the kiln down to 500, and then take this thing back up to 500. Looks good. It's going to take a while for it to come down. In the meantime, we're over at the lathe working on this other part. Okay, well, he wants to reproduce this part, and the wooden shaft is the kind of mock-up for the metal shaft with the spline. So he wants to reproduce the shaft, and because this is cast iron, and he wants to weld the shaft to the and that's my wife calling. So we've kind of gotten started welding that, or machining that down, and we'll be back. Well, the way I had that set up, the plate just wasn't far enough out this way to do the one side, you know, without it being a problem. So what I'm doing now, I'm going to put a couple of parallels in here and push this thing up against the parallels and close it up as much as possible, and then we can pull the parallels out. Come on. If we can get the parallels out. Now that sucker is in there tight. Okay, so we should that's pretty good. Well, not this way, but this way. All right, so what we need to do is looks like that's about good and tight all the way around. Pretty close. Let's get a indicator in there, and we'll see what we actually have. Okay. We're going to have to kind of come in at an angle. Not the best of situations, but it's pretty good. Okay, so here we're high. Let's take this one down a bit. Looks like we got it within about 5 right now. Within about 2 or 3, I can live with that. Let's see what it looks like. That center spins beautifully. Now we are a bit off there though. Can we make up for that? What's our total width? Is okay, so we've got this nice surface here, and we're going to start with that at 0, and we've set the DRO, and we're going to go in 475 thousandths. So let's do that. Okay, we're all within fairly close tolerances. Now it's time to drill the hole, and I've done a pilot hole, and now we're going to come in with a bigger drill bit, take it up to something close. All right, I think we'll take it up to 3/4 and then bore it from there. All right, that's it for today. We got 3/4. We're probably going to take it up to somewhere around 7/8 or something like that. It doesn't really matter because I've got to cut the shaft down to fit that. So we'll be back sometime. Okay, well, as you can see, that little part right there, I went back in afterwards and sharpened that on the diamond grinding wheel. And really, the diamond is the only thing that could touch that. Sharpened each one of them, and we've got pretty much razor sharp edges there. I came back in on top here with my little diamond, you know, grinding stone. I'm not sure what it's called. You know, it's a plate, a metal plate with diamond embedded. And just kiss the tops of these just to kind of get rid of the roughness. And we've got ourselves a cutting edge. All right, well, so first things first, we've got to figure out how deep these splines are so we can cut the shaft to the right depth. So I just bent a piece of brazing rod, and now I'm gonna put, let's see if we can do this. Put a piece of, or put a scale in there, and then bring this back out, and there's our measurement. It's not a tight measurement, it's just a general. I want to have enough spline, and we could probably go over just a little bit too. I'm thinking, what, 700 thousandths? I'm thinking that's plenty. So 700 thousandths, and our total length is, I'm going to bring you over here so we can look at this. I'm not sure you can see it. Bring it in a little closer. There we go. And our total length is 1 inch 750 thousandths. So we've got 1 inch and 50 thousandths to get to that surface right there. And then our distances are 1/4 inch, 150 thousandths, and 1/4 inch. Now I just took some rough measurements while the customer was here. So let's get some more accurate measurements. Alright, so we're going to take this 4140 and we're going to trim it back about 1.5 inches or 1 3/8 inches. And let's measure that. 375, and that's about where we want to go. And that measurement is pretty random because really the spline is only going to be 3/4 of an inch, and the rest is going to be, you know, the trail of the spline. So we're going to take it down to 890. So let's get started. Whoa, we're not going to start with that, are we? I forgot, we're in the 3-jaw or 4-jaw chuck. So let's bring that down. Okay, we're somewhere around 880. It's not critical because we're going to come back in afterwards and bring it down to the exact measurement. We're at 885 right now. So that's a good start. And I want to knock that edge off. And again, when we come back in to finalize the diameter, we'll go ahead and give ourselves a really nice chamfer there. Alright, so that's ready to go. I'm doing a second one just because I know myself, and sure enough, I'll screw it up somewhere.